Have you had this experience? You're using an LLM to write code, and it feels like magic. You describe a feature, it codes something. It looks great. Then you say, "Oh, actually, can you make that multi-user?" And collapse. The logic breaks. The AI gets confused, it forgets the original constraints, and you end up with a mess. Why does this happen? Why are these tools so brilliant one second, and so fragile the next? Well, a new research paper just revealed the hidden reason why, and it perfectly explains why a tool like Crevo was built the way it is. Here's the core problem. In the real world, we rarely articulate all our requirements perfectly in one go. We clarify our needs through an iterative, multi-turn conversation. But it turns out, LLMs are terrible at this. Recent research shows that the success rate of large language models drops significantly, plummets, in multi-turn, underspecified conversations. This is a massive challenge for any AI programming tool that's built on a simple chat model. In a May 2025 paper titled, "LLMs Get Lost in Multi-Turn Conversation," researchers tested over 200,000 simulated dialogues across 15 different mainstream models. They compared two methods: one-shot prompting, giving the AI all requirements, features, and constraints at once, and multi-turn refinement, clarifying needs step by step, just like we normally do. The results? When given all the context up front, the success rate was 78%. When using the step-by-step conversational method, the result is quite different from before. The success rate dropped to 54%. That's a 39% drop in performance. The paper found that as the conversation goes on, the models suffer from aptitude decline and reliability collapse. The takeaway is simple: LLMs don't handle partial context well. They perform best when they are given the whole picture, up front. This leaves developers in a tough spot. We rely on progressive clarification. We tell the AI the goal, let it code, and then say, "Add this," or "Change that." But if the model misunderstood something early on, no amount of correction can fix that broken foundation. At the same time, we can't be expected to write a 10,000-word mega prompt with every single requirement before we even start. It's just not practical. This is the exact problem Crevo was designed to solve. Crevo's solution is to create a balance. It lets you work iteratively, while ensuring the AI always gets the full context. How? Through layered docs and context retrieval. Crevo organizes your entire project into structured, retrievable layers: your user stories, your PRD, your system architecture, your database design, your API specs, everything. So, when you start a task like, implement the user login endpoint, Crevo automatically retrieves all the related fragments: the user stories about login, the database schema for the users table, the API contract, and even the UI mockups for the login screen. It then composes all of this into a complete, unified context and hands that to the model. You see the difference? Even though you are working iteratively, the model is operating in a quasi-single-turn environment. It always has the full picture. When you add a new requirement, like include CAPTCHA and remember me, Crevo simply reassembles the updated full context and regenerates the complete version. No more forgetting, no more cascading errors. Crevo's philosophy isn't about writing better prompts, it's about building better context. By structuring all your project information into a context graph, Crevo gives the AI true, project-level memory. The future of AI programming isn't about crafting smarter prompts. It's about engineering smarter context. The next evolution isn't code first. It's context first.